Hello, this is Jack Jackson. We're going to start talking now about one of the coolest things in geometry, and that is classifying quadrilaterals. One of the things that we like to do as humans is to classify things, sorting them into various types and categories. And this is an important part of mathematics. Notice that we've already worked quite a bit on classification when we talked about different types of triangles, especially in developing the classification tree for subclasses of curves that we've done just a couple of videos back in this playlist. The following classification task is an excellent class to do with a group of high school students or junior high students. It could be your advantage to do it as well. So oftentimes I do this as a group project in class. But if you haven't done this yet, here's what I'd like you to do. See if you can think about this. How should we go about classifying different types of quadrilaterals? What properties are shared by all quadrilaterals? We talked about that some in the last video. What are some interesting characteristics that you could have for some quadrilaterals, but that don't work for all quadrilaterals? Think about how many different ways you could classify quadrilaterals. Write down as many different ways as we might do this. At this point, we don't want to focus on the possible names of these classes, although you probably know the names of some of them, but rather just list the characteristics which define the class. Next, look at the following Euclidean quadrilaterals and determine which of them are in your various classes. Produce as many different ways of classifying quadrilaterals as you can before continuing on, and look back at these and see which ones go in your classes. Actually, looking at these figures might inspire you to come up with some different classes. So I want you to actually do this task right now. This is a really good task. Think about what kinds of classes you can come up with. Once you've kind of exhausted all the different ways you can think of, come back, okay? Press pause right now. All right, you're back. So hopefully you have done this task and come up with some different ways of classifying quadrilaterals. Now think back about triangles. With only 3 sides, 3 interior angles, and no diagonals, there were not many ways to classify triangles. We were able to classify them according to their sides and their angles. But with quadrilaterals, there are 4 sides, 4 interior angles, and 2 diagonals. This results in many different interesting ways we can classify subclasses of quadrilaterals. You might have classified them according to some of the following criteria. Perhaps you even came up with some other additional criteria. So here are some ways that I came up with. The first one is you could look at congruent sides. Okay, the number and position of the congruent sides. For example, you might say, okay, there's a class that has no pair of congruent sides. And then you could have a class that has one pair of opposite congruent sides. Or just maybe one pair of congruent sides, period. Maybe a little bit less specific. Or maybe you want to be more specific and say one pair of opposite congruent sides. And then what about this? Did you use the word at least, at most, or exactly? Do you want to say at least one pair of opposite congruent sides? Or do you want to say at most one pair of opposite congruent sides? Or do you want to say exactly one pair of opposite congruent sides? Each of those adjectives is important in deciding how you set up certain classes. Well, of course, you can have one pair of adjacent congruent sides, or 2 pair of opposite congruent sides, or 2 disjoint pair of consecutive congruent sides, or 3 congruent sides, or all 4 sides congruent to each other. There's a lot of different combinations you can get there of congruent sides. Well, so that's basically on the side lengths, which is how we determine congruence. Okay, but we could also talk about parallel sides. Remember, 2 sides are parallel if the lines containing them are parallel. Okay, how about one pair of parallel sides? Again, did you say at least one pair of parallel sides, or at most one pair, or exactly one pair? Each of those adjectives makes slightly different classes. Or how about 2 pair of parallel sides? Did you think of that one? Some of these you may know names for. For example, do you know the name of this one? Quadrilateral with 2 pair of parallel sides? Yeah, that's a parallelogram. How about a quadrilateral with 4 congruent sides? Okay, that one's called a rhombus. Some of these words may be new to you. Some of them you may have heard before. How about classifying according to properties of angles? Here's some different things we could do with angles. We could again talk about, instead of congruent sides, we could talk about congruent interior angles. Okay, say one pair of opposite congruent angles, one pair of consecutive congruent angles, or just maybe one pair of congruent angles, period. Two pair of consecutive congruent angles. Two pair of opposite congruent angles. Three congruent angles, four congruent angles. Okay, four congruent angles, call that a rectangle, right? The number and position of right angles. Could have one right angle, two consecutive right angles, two opposite right angles, three right angles, four right angles. Four right angles is once again a rectangle. So maybe some of these classes are identical or that they overlap. Okay. Well, you got something else that you have in quadrilaterals you don't have in triangles, and that is diagonals. So you could talk about the diagonals either being intersecting or non-intersecting. That would be two different classes we could look at. How about if the diagonals are congruent? Might be interesting class to look at. Or what about bisecting diagonals? What about one diagonal bisects the other? Or maybe both diagonals bisect each other. Those turn out to be interesting properties by which we could classify quadrilaterals. Or maybe the diagonals are perpendicular. Or maybe one diagonal is actually a perpendicular bisector of the other. Or maybe both diagonals are perpendicular bisectors of each other. And one thing that will make use of our triangle stuff is take one diagonal and the sides and make a pair of congruent triangles. Now it turns out there's actually 6 ways this can be done. If you take quad ABCD, okay, so you start with quad ABCD, then we could either have and diagonal with diagonal, what diagonal is it? It's AC. Okay, then that makes you're going to have triangles ABC, and then you're going to have a triangle ABD. But because of congruence is a congruence, not just congruent triangles, there are 6 different ways you can make those corresponding to the 6 different orders of taking the letters A, B, and D. So you could have triangle ABC congruent to triangle ABD, triangle ABC congruent to triangle ADB, triangle ABC congruent to triangle BAD, triangle ABC congruent to triangle BDA, triangle ABC congruent to triangle DAB, and triangle ABC congruent to triangle DBA. Once again, these are not just saying the two triangles are congruent, but how they're congruent, how the corresponding parts match up. Okay, what happens in these different classes? Are these different classes or the same class? That's an interesting thing to consider. Another thing is taking either diagonal makes a pair of congruent triangles. This just says, well, with one specific one, you get two congruent triangles. This one says, okay, you do not only do you get congruent triangles this way, if you slice it the other way, you get congruent triangles. So there's probably other ways to look at it, but those are several different ways that we could classify triangles. Hopefully you came up with several of these, but it'd be impressive if you came up with all of them. So let's continue on this idea. When you made your classifications, or we're looking at the ones that I came with up here, once again, modifiers such as at least, at most, and exactly make important differences in how you classify quadrilaterals. Did you usually prefer at least, at most, or exactly in those definitions of the classes that you made? One of the ways you might decide to classify quadrilaterals is by the number of parallel sides. Recall that two sides, line segments, are said to be parallel if and only if the lines containing the two sides are parallel. So remember that's coplanar and non-intersecting for the lines. Quadrilaterals could have either exactly 0, 1, or 2 pair of parallel sides. One of these classes has a name by which you should be familiar. It's a parallelogram. A parallelogram is a quadrilateral with 2 pair of parallel sides. In our next video, we're going to talk about what is a trapezoid and talk a little bit more about the role of definitions in mathematics. So that's a pretty interesting topic that we'll talk about in our next video.